Created by fire and titanic upheavals of the Earth, islands make up 1/6 of the landmass of our planet. They are lenses through which to study the complex workings of evolution.
Tropical islands have been important in the understanding of evolution ever since Charles Darwin visited the Galapagos early in the 19th century. We're going to visit 3 very different tropical islands to see what they can tell us about evolution, even today.
Islands are natural laboratories, full of novel experiments in natural selection and evolutionary wonders.
But there's much more to evolution than the survival of the fittest. The phrase wasn't even in Darwin's first edition of The Origin of Species.
I'm exploring other major influences: geology, geography,
Hello!
isolation and time.
You found this giant stones.
I'll be charting the life cycle of islands, from birth and colonization to the burst of evolutionary creativity that often accompanies maturity.
They take the leaves so delicately.
And what eventually happens when an island grows old and nears its end.
You can almost feel this unforgiving rock return ultimately to sea level.
Places of extinction as well as creation. Our story will reveal evolution in action.
We just discovered new species of the mouse lemurs.
So mouse femurs are still actively evolving.
Yeah.
And how life generates abundance, even from a blank slate.
Islands are the ideal place to understand the rules that govern evolution.
Madagascar is an island of great antiquity, where the eons have created almost a separate realm of animals. Of the 250,000 species that live here, more than 90% of the island's amphibians, 70% of its reptiles and plants, as well as half its birds, and almost all of its spiders and insects, are endemic. Natives that are found here and nowhere else. To solve the riddle of how such extraordinary diversity was created, I first need to see one of its most charismatic animals. Animals whose ancestors arrived here, probably on a natural raft of vegetation, some 55 million years ago. Primates, related to modern monkeys, apes, and even us. The lemurs. The ancestral lemur survived crossing several hundred miles of ocean to find itself marooned on a nearly uninhabited island. The 4th largest island in the world, Madagascar, is 250 miles off the east coast of Africa, 1,000 miles long and 350 miles at its widest point. Descendants of the first primates that landed all those millions of years ago can be found on a series of smaller islands set within a Madagascan river. But these islands are not all they seem.
It looks like a jungle, it smells like a jungle, and it is a jungle of sorts, but a bogus jungle. Welcome to Lemur Island. Not quite a zoo, but it certainly ain't natural. Hello, little guy.
Just a short paddle across the man-made river, tourists from the nearby private lodge can get up close and personal with as many as 6 captive lemur species from different parts of Madagascar.
Well, he's looking round for the next banana. I'm just a passing fad.
lemur's exile in Madagascar has favoured the retention of traits some other primates have left behind. Lemurs are different from monkeys. Lemurs are related to bush babies and lorises, and like them, they have a nose which sort of listens. They're called strepsirrhini. For these particular primates, the sense of smell is all important. Whereas for the monkeys and the apes, and indeed ourselves, we've rather relegated smell to a secondary position, and we rely on our sight, on our wonderful vision. It's likely that the moist-nosed animals evolved first, and it's generally thought, of course, that these animals are a more primitive or basal group. The ancestors of the lemurs arrived on Madagascar around 10 million years after the mass extinction event that wiped out the dinosaurs and many other animals. The island they found almost completely lacked predators, or indeed competitors, and was richly endowed with different habitats. Adapting to these new circumstances triggered the evolution of many specialist species. Today, there are no fewer than 106 species of lemurs. That's almost as many as all the species of monkeys living in Africa and Asia combined. Biologists call this process adaptive radiation, and it's a particular feature of island life where isolation creates an abundance of opportunities. This really beautiful animal is the diadem sifaka, one of a dozen species in Madagascar. All these lemurs seem to have a different livery to help them recognize their own kind. Sifaka lemurs feed primarily on leaves. Their specially evolved stomachs can process deadly alkaloids most other primates would strenuously avoid. To see the largest living lemurs produced by this burst of adaptive evolution, I visit the remote Mitsinjo Forest Reserve. I'm with Dr. Rainer Dodge and guide Regis Razafiarizon, who have spent much of the last 20 years trying to protect them. I'm in this fragment of Madagascan rainforest in search of a large lemur that doesn't really respond to being kept in captivity. You just have to examine it in the wild. Indri live in troops of 6 to 8 individuals, led by a dominant female. Their song is the most complex of all lemur species, which not only marks out their territory for neighbouring groups, but is used for warnings and bonding.
Do you hear that wailing sound over there?
It's distant, yeah.
So I think we're fairly close. That's their territorial call. And I think we just move that direction and try if we find the group.
That's a lovely view.
So do you see the two? This one's a bit further down.
Yeah.
But it's usually the female that leads the calls.
And it's a surprisingly effective call. It carries a long distance, doesn't it?
It does, yeah. You can hear it even in the village, which is like 3 kilometers away from here. So they delineate their territory by calling every morning.
So they distinguish themselves from other bands.
They distinguish themselves from other bands, but they're also communicating within the group, because at some point the group will actually be spread out quite over a large area.
The Indri has evolved to feed on a wide variety of leaves and flowers, only found in the ancient Malagasy rainforest. Rainer and his team have been monitoring this particular family for several years now. To see if he can get us a little bit closer, Regis has brought them some of their favourite leaves.
We try to tempt them down and lure them towards us, if you like, and, well, let's see what comes out of it. But Regis has done that for quite some time, so we can just trust him and follow him. And it's coming. There you go.
Beautifully versatile hands and the forward-looking eyes and so on that reveal its primate.
Yeah, totally. I mean, the hands, if you look at them, they're quite human-like.
We can also see this delicate way of nibbling leaves, so it's a leaf connoisseur.
Yeah.
Could I have a closer look
Sure,
myself?
yeah. Let's approach them a bit.
They take the leaves so delicately.
Malagasy legends revere the Indri as man's closest relative, a long-lost brother who still dwells in the forest. The Indri has evolved a specialized diet that requires it to forage over large areas, restricting the places it can live and limiting its numbers. But no such limits apply to my next lemur, a small generalist whose rapid evolution has allowed it to spread to different habitats all over the island. To see one, I travelled to the Botanical Gardens and Zoo of Tsimbazaza and meet Madagascar's leading primatologist.
I'm with Professor Jonah Ratsimbazaft, and we're looking at the mouse lemur, the smallest of all living lemurs, and indeed the smallest primate. Well, Jonah, the great bulbous eyes mean certainly nocturnal.
Exactly. They are very, very dynamic when it's dark.
They look as if they've got kind of those insectivore faces.
Yes, they eat mostly insects. That's where they can find animal protein.
And how long do they live?
Most lemurs can live up to 15 years.
So for an animal of that size, that's quite extraordinary, isn't it? What does it weigh? I mean, what is
The smallest mouse lemurs weigh only 30 grams.
Even though this mouse lemur looks like other mouse lemurs, in fact, it is a recently evolved, distinct species.
The other interesting thing that's recently been discovered about these sorts of lemurs is there are more species than we thought.
Yeah, in the past, we just thought that there are only 2 species of mouse lemurs, but we just discovered new species of the mouse lemurs, and this is one that we discovered.
So this is because the genetics, the genome of these species is different,
Exactly.
even though the appearance is superficially very similar.
Yeah, there are more than 20 different mouse lemurs in the island of Madagascar.
And are they only found in the rainforest, or can they survive in the cleared forest?
Mouse lemur you can find all over Madagascar.
So they're actually very adaptable little animals.
They can adapt very, very easily in their natural habitat.
One of the reasons for the success of the lemurs is the rarity of predators. But ancestors of one major carnivore managed to reach the island from Africa before humans arrived. The fossa. It is both very rare and very shy, and in the wild ranges over wide territories. In captivity, its young are so naturally ferocious, they can only be fed live food.
The top predator, the fossa, is quite capable of chasing after lemurs in the canopy, as well as birds. It has a very cat-like appearance, perhaps, particularly with its long balancing tail, but actually it is related to the mongoose, which, of course, is an African neighbour. It's really quite a fearsome predator.
The osse's long tail make it extremely well adapted to hunting in the trees. But Madagascar's predators come in unexpected shapes and sizes. This small chameleon belongs to one of the oldest and most diverse radiations of animals on the island.
So look at this little chap here. It's a small Columagastratinia. Just woke up.
So walking slowly, but they always walk slowly.
They always walk slowly, and it always seems that they do 2 steps forward and 1 step back. That's obviously a camouflage against predators, because they look like leaves moving in the wind.
Now, Madagascar's really the home of the chameleon, isn't it?
That's true. I mean, you find more than half of all the chameleon species of the world in Madagascar. It really has developed from the north to the south, from the rainforest to the dry forest. If you're small like this chap, you would obviously go for really small flies or small crickets or something like that as your prey.
This tiny chameleon weighs only a few grams. Like this cricket, it would also provide a tasty morsel for its largest relative. Just one of the 75 different species on Madagascar. So we've seen the smallest, and this must be, what, the largest?
This is one of the 2 largest chameleon species in Madagascar and the world. This is Parsons chameleon, and is actually named after a parson, as you may have imagined, actually a missionary that worked in Madagascar in the 19th century. So it can grow a bit bigger than it is at the moment, but that's already an impressive animal.
And does it live high in the canopy?
It lives high in the canopy, and up there it feeds on large insects such as dragonflies or large crickets, and, well, eventually other chameleons that are smaller than him.
When I first looked at these things, I thought they've only got 2 toes. But then I saw inside, I could see the bones of the normal fingers. 5 toes, but bundled up.
Well, those toes are an adaptation to arboreal life, and so that gives them a shape of their feet with which they can actually grab the branches they're walking on. Just like, look at it, how it can suspend itself, like just clinging on my arm.
But not all chameleons live in trees. Unlike the lemurs, whose original ancestor has long vanished, the relatively primitive chameleon settlers still live alongside more recently evolved descendants.
Look what we have here. Do you see the animal sitting on the leaf there?
What a handsome fellow. Looks like a minute Triceratops dinosaur. So is this the horned chameleon with its pair of horns at the front?
It's actually called the Brookesia superciliaris, so the horns are a bit reminiscent of giant eyebrows, hence the name.
But it's on the ground, of course. It's not on the branches.
It is a ground chameleon, so it would actually go on the forest floor during daytime and forage, and then only at night would it climb up on small branches to go to sleep.
And you say it's a relatively primitive one?
It is a very basal chameleon on the chameleon phylogenetic tree.
So that means that ground hunting probably came before arboreal hunting for these animals. So what we're seeing here is the sort of basal part of an evolutionary radiation.
That's right.
But instead of the species dying out, as you might expect, they're all still with us. An evolutionary scenario that allows both ancient and recent forms of related animals to live alongside one another is rather unusual. What allowed this to happen on Madagascar? The answer is time. "80% of all islands in oceans are created by volcanoes rising up from the seafloor in just a few million years. Madagascar is different. It was born when the ancient supercontinent of Gondwana was pulled apart by the inexorable forces of plate tectonics 200 million years ago. By 90 million years ago, Madagascar had been transformed into an island. This massive rock is granite. And the presence of granite is proof enough that Madagascar was once part of an ancient continent. It's an acid rock,
as geologists say, full of quartz. And where granite weathers in a tropical climate, it does so to a red material called laterite. And in the rainy season, the rivers run almost red as blood as laterite is washed out.
Millions of years of erosion from weathering and rivers have created numerous habitats. And this great variety has in turn created a vast number of different ecological niches, providing many opportunities for different species to adapt and evolve. One way to envisage an ecological niche is to imagine dividing up a habitat into different packages. Each package or niche can be differentiated from the others by such factors as the amount of sunlight or rainfall it receives, the resources it can provide, and crucially, whether it is already occupied by other potential competitors. In Madagascar's rainforest, frogs have occupied numerous special niches, partly because they're the only amphibians to have colonized the island. Toads and newts never made it. At the Amphibian Survival Assurance Centre of Andasibe, scientists are trying to discover more about Madagascar's numerous species of endemic frogs.
Come on in. Oh, wow, so this is your frog heaven. That's not the right term.
To protect them from invasive diseases, Dr. Devon Edmonds heads a captive breeding program.
Well, I'm looking for the frogs. I can't actually spot one, but you'll no doubt... Oh, yes, I can. Right in the middle there.
Yeah.
Tiny brown frog with a tiny white spot on its nose.
His research vividly demonstrates how separation of populations might trigger the appearance of new species.
We have one species here that looks almost identical to another in our forest that we have here. The only way to really tell the two apart is to listen to their calls of the males.
And that's quite sufficient to keep the two species absolutely separate. Presumably you prove that by molecular studies as well.
Yes, yeah, exactly.
So, and how recently was this recognized?
In the last decade. And the species with a different call that looks the same as this one is not described yet. So
it doesn't have a scientific name?
It doesn't.
So we're watching the very birth of new endemic species here.
Yes, exactly. This represents kind of a complex of species. I think there's more than 8 or 9 now that are kind of recognized as being different species in different parts of the island, but they all essentially look like this.
Fossil evidence of frogs dates back to when Madagascar was still part of Gondwana, and when giant reptiles still ruled the earth.
There are more than 300 species of endemic frogs in Madagascar. Many of them tiny, like the ones we've looked at, but some slightly larger. But the largest frog that ever lived was also found in Madagascar as a fossil, a contemporary of the dinosaurs. It was 16 inches across, probably weighed more than 4 kilograms, and some people think it probably ate baby dinosaurs.
Beelzebufo's disappearance shows the isolation offered by an island is no guarantee of long-term survival. Fears of another wave of extinction are the reason why the Survival Centre in Andasibe was established. Devon's team conduct regular nocturnal surveys, capturing and swabbing local species to test for the presence of a new invasive disease, chytrid. It's a deadly fungus which some predict could make a third of the world's amphibians extinct. But what no one yet knows is whether Madagascar's endemic frogs will be more or less vulnerable to it than those found elsewhere.
The disease can't be removed from the environment once it's introduced, and if we're not looking for it, we won't know if it arrives. And in the worst case scenario, you can lose a third or more of the amphibians in a pristine habitat over the course of a few months. So it can be pretty dramatic, have a pretty dramatic effect on the forest, especially in areas where there's a lot of diversity like Madagascar.
an animal that shares the tree-living niche of many of Madagascar's frogs, is lurking in the rainforest. But it has evolved a strikingly different specialization to survive in the dense forest.
So, Richard, on this tree, some of the guides pointed to me out earlier that there is a very interesting animal sitting on that particular tree.
You mean that little thin tree?
Exactly. So well camouflaged that it is the same color as the bark.
Right, well, I'll start looking at the bottom and I'll work my way up.
Yeah.
So, up. Are you going to give me a hint?
Do you see the point where this branch is sticking out of the stem?
I think I finally twigged.
If I just can point it out to you.
It's head down.
Head pointing down.
Yeah.
There you go.
Well, that wins the prize, really, doesn't it, for camouflage?
It's a leaf-tailed gecko, actually, and it's another Malagasy endemic. And it's so well camouflaged because if it wasn't, then a lot of birds would prey on it. And so it would actually stay on the tree well camouflaged.
Absolutely motionless.
Totally.
So I guess these geckos have had their own radiation here. Did they come over, do you think, about the same time as the lemurs, 40 million years ago-ish?
Yeah, that's very probable because they must have come when the ocean currents permitted them to raft over from mainland Africa.
But that was presumably after the big extinction that removed the dinosaurs and a lot
That's right.
else.
So they are reptiles that came after the dinosaurs went already extinct.
And then took off onto their own little Madagascan radiation.
That's right. And all the gecko species that we have in Madagascar are actually endemic.
I love it.
And once night falls, our once invisible gecko wakes up to become a formidable insect hunter. One of the endemic insects it preys on has evolved features seen here on Madagascar and nowhere else. To claim its mate, it really sticks its neck out.
One of the most extraordinary creatures, if most diminutive, in Madagascar. It's the giraffe-necked weevil. It's the male, and only the male has this extraordinarily extended neck. And it's not surprising to learn that it's used to battle other males. The one with the longest and strongest wins the attentions of the female, which has no such long neck. It's a very special kind of adaptation. The female has a short, stubby neck and rolls up the leaf of its favourite food plant into a sort of cylinder and lays its egg there. The cylinder falls to the ground and the next generation is nourished. Of course, it's a beetle, so it has wings that are folded under the scarlet wing cases. And it's quite capable of flying off. In fact, I can see it flexing its wing cases even as I speak. It's probably searching a male to fight, or maybe a female to mate with.
Most colonists that arrive on a remote island like Madagascar, full of opportunities, have ample space to radiate and evolve, becoming the forebears of many new species. But sometimes a plant or animal breaks this general rule. Eddie Manatijara is searching for an epiphyte, a plant that grows harmlessly on another plant. It favours inaccessibly high tree branches. Yet despite having such an elevated niche high in the canopy, this plant's status is more akin to that of a fugitive. Because in the game of radiating into new niches,
A special treasure.
it did not pass go.
What may not look the most exciting of plants. It's a cactus, and it's called Ripsalis, and it's the only cactus in Madagascar. Other species of Ripsalis are found, for example, on the southern part of India. So this is a relic of the ancient Gondwana continent. But it's also interesting from another point of view. We're used by now to seeing radiations in Madagascar. Different groups of animals and plants filling a whole range of ecological niches and producing lots and lots of species. The cacti didn't do it. So this, you could say, is the exception that proves the rule.
The cactus's failure to radiate left many of the dry habitat niches which have been occupied by cacti elsewhere free for other plants to exploit. But in order to adapt to these habitats, many of these plants in turn became very cactus-like, resembling this euphorbia. It's a process called convergent evolution. Having spent 4 decades studying the history of life since the earliest times, there is something particularly fascinating about seeing how nature keeps reinventing the same traits in different organisms.
These are giant pill millipedes. It's a particularly wonderful animal for me to find because it reminds me very much of the trilobites I studied for so many years at the Natural History Museum, many of which could also roll into a tight ball just like this animal. He's not very frightened of me though, because he's unrolling almost immediately. There you can see the legs on the underside, kicking away, you see. Well, I've seen animals more than 400 million years old that look remarkably similar. So for me, I'm looking back hundreds of millions of years into the past, even though these animals probably evolved here, well, I would say only a few tens of millions of years ago. Of course, there's no question of these being other than the most distally related, and they're both arthropods. It just shows that common problems promote rather similar solutions. Another example of convergent evolution. Aren't they wonderful?
My next example of convergent evolution is a nocturnal wanderer. Quite spooky. But there's a family of woolly lemurs, just woken up, I suppose, and on the night shift. But that's not the special animal I'm after. In the depths of the Mitsinjo Forest Reserve, the populations of other elusive animals are being monitored and studied. The reserve has a research project, which means they put down pitfall traps and trap animals that have been walking around on the forest floor in the dark. My quarry is both strange and strangely familiar. You might be reminded of something in your garden.
Fantastic little animal. Beautiful. There we are. Well, it looks just like a hedgehog. And that's not a coincidence, because it lives just like a hedgehog. It eats worms and other invertebrates, mostly nocturnally. But it's no hedgehog. It belongs to a completely different group of animals. In fact, this is a tenrec. Its closest relative outside Madagascar is probably that extraordinary African animal, the aardvark. It's a fantastic example of convergent evolution. The tenrecs have turned into, more than 20 species of endemic animals in Madagascar.
As well as their protective spines and insect-based diets, like European hedgehogs, in the chillier winter months, this species of tenrec also drops into a form of semi-hibernation, termed torpor. As well as physically and behaviourally resembling other animals, some convergent species have also evolved almost inconceivably similar physiological traits. Madagascar's frogs have evolved defences almost identical to relatives that live thousands of miles away that they can never have encountered, let alone interbred with. One example was rescued by Dr. Devon Edmonds.
So these are brilliant orange frogs. In amphibian, usually orange bright colours are a warning sign. Is that the case here?
This is exactly the case. Yeah, these bright coloration serves to warn predators that they're poisonous.
So, what sort of toxin do these frogs have?
They have several kinds of alkaloids in their skin that are distasteful and poisonous to predators, which they get from the prey that they eat. Things like ants or beetles or mites.
So they take the poison from the prey and plaster it on the outside?
Exactly.
I've seen frogs brightly coloured like that in Central America.
Yeah, this is kind of an interesting case of convergent evolution, where you have two frogs that are totally unrelated to each other, evolving in basically identical ways. So these frogs actually have the exact same alkaloids in their skin as the South American and Central American relatives.
That really is quite extraordinary. This must have taken millions of years for sure for this sort of sophistication to arise. But it's quite extraordinary to think that this could happen twice in such a similar fashion.
But the prize for the most unlikely example of how one animal has evolved to fill almost exactly the same ecological niche as another goes to a notoriously reclusive animal feared by Malagasy folklore. To all intents and purposes, it earns a living the same way as a woodpecker. It even builds a nest. But it's actually a type of lemur.
If you look at the eye has big ears. To hear the larvae in the trees, they listen first to hear the noise, and then the teeth, very strong incisor to break
wood.
The woods. Then they use the fingers to eat the larvae.
So like a hook.
Like a hook to get the larvae.
I mean, if this is so different from the other lemurs, it implies this has a long independent history.
Exactly. So once they come to the island, there's a huge radiation, and the eye separate from the rest of the lemurs. They have their own evolution. In the past, people thought that the eye was like a rodent because of the teeth, but the eye live like birds. They build nests.
So it's about as specialised a niche as you could possibly imagine.
None of the lemurs has that features. It's just the eye.
The eye is such an extraordinary animal, you simply couldn't make it up from first principles. Today, this highly evolved loner is under threat from a gregarious generalist. Homo sapiens was the last primate colonist to reach Madagascar, but already this species has left an indelible mark. Surprisingly, the first human settlers to reach the island came not from Africa, 250 miles away, but from Borneo, more than 2,500 miles away. The reason was a change in ocean currents, which after millions of years of flowing west to east, changed to flow east to west, thus allowing early Bornean seafarers to drift gently with the currents to traverse the Indian Ocean. They settled in Madagascar's Central Highlands, where they cleared the forests and started creating terraced paddy fields to grow rice. And here is hidden, tantalizing evidence for early human encounters with some of the oddest creatures ever to live on Madagascar. The first fossil clue that led scientists to search for these now-vanished animals is to be found in the village of Sambaina. It's kept in a house owned by its discoverer, Mrs. Medulin.
Ah, hello. Salama.
Salam.
Mrs. Medolin.
Salam.
Now, you have some bone here to show me. And you found this. You found this. These are bones, giant's bones, found by Mrs. Medolin in a nearby field. Thank you very much for showing them to me. We'll go and see if we can find them in the place where they occur, very near here.
My fellow paleontologist, Karen Simmons, and her team have been excavating a paddy field site for only 2 seasons. But every day, new finds are rescued from the mud.
Well, it's actually a funny story. We knew people found fossils from around this region, so we actually just found a spot to dig 2 simple pits, and in those 2 pits last year we found more than 100 fossils.
So an instant bonanza.
Yes, instant, but that's the way we like it. So
But just looking round, I can see it's a virtually horizontal plain surrounded on all sides by hills,
Yes.
which makes any geologist think a lake.
yeah, so we have good evidence that this whole region was a giant fossil lake. The mountains that we see here are volcanic mountains. These mountains came up, and when they raised, it actually prevented some of the rivers from flowing west, and that region, the whole basin, then filled with water, forming the giant fossil lake. When it was a lake, it undoubtedly supported all sorts of different kinds of animals that relied on it and lived within it, and those are the animals that we find today.
Oh, so what have we got here?
So this is part of an elephant bird, bone from the leg. So you can imagine how massive this bird must have been.
It's huge.
It's a huge bird, bigger than either of us.
And pretty strong.
Very strong, yep. And inside of the bone, you can see, has a lot of these openings and holes. So even though it's a mammoth size, it still shows the signature of a bird, which is to try to lighten that, even that big bone.
Flightless, needless to say.
Yes, a flightless bird.
And quite a lot of meat on it, I imagine.
Quite a lot. In fact, you can imagine those animals would have been quite a prize for someone who wanted to
Big
hunt
chicken dinner.
a big chicken dinner, yes. This is the jaw of a pygmy hippopotamus, so you can see here's one of the teeth. So to us, I mean, this looks pretty big, but if you compare this to the size of an African hippo, say...
Oh, you're talking that sort of size.
Exactly. So these guys went small. We have some things on islands getting small and other things like the elephant bird getting really large. That's a common pattern on islands. Here's another hippo. Here we go. This one you can see more of the
Oh, yeah,
teeth.
you see
Yep.
those are the anterior.
Those are the
front teeth,
anterior
yeah.
front teeth projecting forward. Here's some of the molars. And so if we had to do a count, I'd say more than 80% of what we find is actually pygmy hippo. So there you go.
And did this pygmy hippo overlap with the arrival of Homo sapiens?
It certainly did. And in fact, there's even some bones, cut marks on hippos, where you actually see butchery marks, people that must have hunted them and eaten them.
So that's almost the smoking gun.
Yeah, certainly we know that they interacted and humans must have prized them for hunting.
Pulling bones out of mud is exciting. But what's really exciting is piecing those bones together to find the complete skeleton. And here we have the brontosaurus of the bird kingdom, the elephant bird, Aepyornis. And what a creature. Well, you can imagine its succulent thighs, its huge quantity of breast meat. As for the brain, well, it's got a very small brain case, so it was certainly no intellectual giant. But that hasn't stopped emus and ostriches doing very well for themselves and still with us today. All a question of niche, as usual. But I suppose the real vulnerable spot for this animal was the egg. Probably the largest egg that ever existed. 20 omelettes in a single shell. They once thronged in huge numbers all over Madagascar. And it's so sad that they're no longer there today. I would love to have seen them. Well, we found the jawbone of this animal when we were in the field. It demonstrates another rule of island life. As well as things getting larger, some things get smaller. It's a pygmy hippopotamus. It's actually relatively easy to change size. It doesn't require a great deal of genetic reorganization. So, if food is short, or food changes, or the niche changes in some subtle way, then size change is relatively easily achieved. There were once even more species of lemur in Madagascar than there are today. There were ground-dwelling lemurs, Megalodapis, example of island gigantism. Sadly, none of them survived the arrival of the human. Today, the bustling capital of Antananarivo is a melting pot of different peoples. The first settlers from Borneo were followed by waves of new colonists from Africa. People from India, the Arab world, and China joined the melting pot. Finally, the arrival of Imperial Britain and France in the 19th century began a profound transformation. European plantation owners introduced eucalyptus trees to the island. And the dire consequences of this are still being felt today.
This scene says it all, really. Behind me, a great swathe of felled eucalyptus, and here it's being turned into charcoal in this smouldering heap. The population of Madagascar is increasing at a tremendous rate, and you can understand why, in some ways, eucalyptus is regarded as a very useful crop. But of course, it's also destroying the ecology. And here's the almost indestructible eucalyptus already regenerating from the charred stump.
Around 80% of Madagascar's remaining forest is now being used to grow eucalyptus trees for charcoal fuel. If this rate of habitat loss continues unchecked, by some predictions, 90% of the country's wild lemurs could be extinct in just 20 years. I can only hope the haunting calls of lemurs, like the Indri, are not a foreboding of how fragile these creatures' future really is. For lemur, in Latin, means ghost.
Madagascar is the place where the ecological niche has triumphed. If there are 100 different trades in nature, there are 100 different species to fill them. The amphibia, the birds, the mammals, it's all the same. They have divided the environment into habitats that they can utilize. And how different this is from the eucalyptus monoculture. That's a kind of monopoly, a single trade, and very few of the animals and plants that live here can cope with it.
I've come back to the pristine forest of the Mitsinjo Nature Reserve. Here, brothers Yusuf and Mad, who run one of the country's reforestation programs, are helping me to find some of the plants that they believe have valuable medicinal properties. The secrets they are uncovering make an unexpectedly strong case for preserving these unique habitats as the island's greatest resource.
Well, it's certainly quite pleasant tasting. Makes me feel rather like a lemur.
It's a sweet tree.
A sweet tree.
Yes.
Now, most of the trees in this forest are not sweet trees. Most of them have unpleasant taste or are actually poisonous. But this one not.
This is not. This is sweet trees. If you get hungry in the forest, these trees can help you.
So if I was really hungry, I would eat one of these leaves and keep me going.
This is part of the coffee family.
Oh, right, a very big family in the tropics.
Yes. Yeah.
And what is it used for?
This is good for the fever.
Also brings down high temperature,
Yes.
which in an area where there is a lot of malaria must be very useful.
Yes. So yeah. And you take the leaves and they cook the leaves and drink the infusions.
Does it taste unpleasant?
Yeah. It's a little bit bitter.
Ah, right.
Yeah.
Ah, plant with conspicuous white berries. What is this one?
This is Malagasy tea. This plant is help us for the blood, high blood pressure.
Ah, right. It produces blood pressure.
Yes. This is a native from Madagascar.
I mean, that's the thing. These forests are full of secret ingredients, really, for human use eventually.
Mm-hmm.
A few of the 600 or more endemic trees and plants have already been used to create new medicines, including anti-cancer drugs.
I'm told that the Malagasy name of this plant means take away all your worries, so I'm looking forward to an infusion of that one.
Youssef and Mad have promised me it is safe to try out some of the leaves we found with my Malagasy meal.
So this is my Malagasy gastronomy. The empty plate. Well, there is no animal source of endemic protein here. Enough tenrecs and lemurs have been eaten already. But I am allowed to eat banana bread wrapped in endemic ginger species. And I may need it, take the taste away. There are several species of ginger in Madagascar, but this one is an endemic species and it should give the bread a special flavour. And it's rather nice. Now, I'm going to start with Malagasy tea. Supposedly good for blood pressure as well. And it's really quite pleasant and quite refreshing. I've been slightly dreading the next one. This is the one that's apparently good for fever. Ugh, and nor does it. It's kind of very bitter, but it's got that sort of it's good for you taste, if you know what I mean. Now, fortunately, I have a brew made from the tree that cures all known ills. Well, I can feel the bliss coming on.
It took tens of millions of years living in rainforests like these for such magical varieties of plants and animals to evolve. Nestled in the branches or creeping through the leaf litter, teem hundreds upon hundreds of species, many still unknown to science. Their fragile lives prove how an island such as Madagascar is both a laboratory for evolution and a haven for the sort of adaptive experimentation that can take place nowhere else. In the next episode, we travel to the island of Madeira, an ark of ancient forests and rich marine habitats. But an island that is approaching the end of its life cycle to return to the sea from which it arose.
If you've missed any of Michael Wood's new series, The Story of China, the first episode is available to watch now on BBC iPlayer, and the series continues on Thursday over on BBC Two. Here on BBC Four, though, we're off to market. Stay with us.